Hello, welcome back. Let's continue on with graphing these problems. And so I know that you guys probably have all of this area taken up. So what I want to do real quick is just graph a couple of, or just plot a couple of these points. All right. So whenever I graph exponential functions, okay, one thing I do is I always choose -1 for x, 0, 1, and 2. And that's about it, okay? Now, when I plug in 0, okay, into any of these functions, I'm going to get the value of 1, okay? If I plug in 1, 3 to the first power is going to give me 3. Okay, if I plug in 2 in for x, I get 3 to the second power, gives me 9. Okay, now when I plug in -1, remember what happens is that I'm going to get, if I do f of -1, it's going to give me 3 to the -1. That's going to give me 1 over 3 to the first, which is just 1/3. Okay, so this value here is 1/3. Now I want to graph these points and plot them. So I'm going to plot the first one as 0, 1, and that point's always going to be there. I'm going to plot the point 1, 3, and then I'm going to plot the point 2, 9. Okay, and then I'm going to plot the point -1/3, 1/3. Okay, and that's going to go right about here. Okay, and so now what I have is what I know is that I know that this graph is asymptotic to the x-axis. Okay, and that's my graph. Now what I want to do here real quick is talk about my domain and range. Okay. My domain of this graph is going to be -infinity to +infinity, or all real numbers. Okay, my range, though, is going to be the value from 0 to +infinity. Okay, and what we know is that whenever we plug in any x value, okay, we're going to get a positive number here. Okay, and the reason why is this. Okay, remember, if I plug in a negative number, 3 to the -1, all that's going to do is put 3 in my denominator, and I'm going to get 1/3, okay? And so that's what happens, okay? So that's our domain, that's our range. Okay, let's go ahead and graph the graph f of x equals 1/3 x. So same thing, okay, but except for this time, because I'm dealing with a fraction, what I'm going to do, I'm going to plug in x values, plug in y values. I'm going to plug in -2, -1, 0, and then 1. Now, if I plug in 0, I'm going to get 1. Okay, if I plug in 1, okay, I'm going to get 1/3 to the first power, which is just going to give me 1/3. Okay, let's go ahead. Let's talk about what happens when I plug in -1 and -2, and hopefully we have some room. Let me do f of -1 here. So if I do 1/3 to the -1. What I'm really doing is I'm taking 1 to the negative first power over 3 to the negative first power. For me to switch that and make those positive, I just reverse and flip my fraction. And that's going to give me 3 over 1. All right, so 3 to the first power over 1 to the first power, which is just going to give me 3. Okay, so when I plug in -1, I get a value of 3. Okay, if I plug in -2, all right, let's go ahead and do that. F of -2, we're going to get something similar. I'm going to take 1/3 and raise that to the -2 power. So that's going to give me 1 to the -2 over 3 to the -2. Go ahead and flip your fraction and make those exponents positive, and we're going to get 3 squared over 1 squared, which is really just going to give me 3 squared, which is 9. Okay, a lot of work goes into this, but it's important that we're able to at least plug in those numbers to see what we get. Now let's go ahead and graph this. So -2, 9 is my point there. -1, 3, 0, 1, and then 1, 1/3. Now what we notice here is that this graph is pretty much the same thing, except for it's reflected over the y-axis. Okay, and that's that. Now let's talk about our domain here real quick. I'm going to write this up here. Our domain, again, is all real numbers, so -infinity to +infinity. And then our range values go from 0 to +infinity, okay? And that's what we're looking for. All right, now let's go ahead and take a look at this next one. Now we're going to use the graph of f of x equals 3 to the x to obtain the graph of g of x equals 3 to the x minus 1 power. So let's just go ahead and graph 3 to the x, which we've already done. So 0, 1, -1, 1/3, 1, 3, and then 2, 9. Okay, And that's my graph for this. Now, what we have here is we have a transformation, okay? So this is a transformation, all right? And so all of our rules that we had regarding transformations also apply to exponential functions, okay? What we're doing here is we are affecting the input. And I'm going to rewrite this. I'm going to rewrite g of x equals 3 to the x minus 1 power. I'm going to put that in parentheses. And the reason why is because this is going to shift it left or right. If I affect my exponent here, that's going to shift it left or right. All right. And so because this is -1, this means we're going to shift right 1 unit. Okay. And what I do is, in order to use this graph, what I'm going to do is I'm going to take all these points and I'm going to move them over 1 unit. And that's going to help me obtain my new graph. So I'm going to plot these new points, okay? And so even though these graphs might be a little bit confusing, okay, they're going to behave the same way, and all we're doing is just shifting it over, okay? Now let's still talk about our domain and range of our new graph. Our domain stays the same, -infinity to +infinity, and then my range goes from 0 to +infinity, and that's all we're doing. Okay, now let's look on the next page and let's see how another transformation works. Okay, so on this one, we want to use the graph of f of x equals 2 to the x to obtain the graph of g of x equals 2 to the x plus 1, okay? So let's just first graph f of x equals 2 to the x, okay? And so first things first, all right, I know I have the point 0, 1. I'm going to have the point 1, 2, 2, 4, okay, -1, 1/2, all right? And we've did this on the previous page in the beginning, okay? If I plug in 2 to the 3rd power, so if I plug in 3, I'm going to get 8, okay? So here's my function. Okay, here's my graph. All right, and what I'm going to do is we're going to do 2 to the x plus 1. So again, this is a transformation. All right. And because we have the plus 1 on the outside, that means we're going to move it up 1 unit. Okay, and so we're going to move every single point up 1 unit, just like how we did in all the other points here. So I'm going to do this. I'm going to take this point here, move it up 1. Take this point, move it up 1. This point, move it up 1. This point, move it up 1. And this point, move it up 1. Now what I've done, here's the interesting thing. Okay, this is going to affect our domain and range, and I'm going to show you why. So right here, all right, we get these new points. All right, here, here, and here. But what happens is because we had an asymptote at 0, now all of a sudden we have an asymptote at y equals 1. Okay, so we have a horizontal asymptote now. So horizontal asymptote at y equals 1. So what that's going to do is affect our range. Okay, so our domain for this function, domain remains the same. All right, -infinity to +infinity. And then our range is going to become 1 to +infinity. And that's how that's affected. Okay, so nothing too crazy, but we just want to make sure that we, graph these appropriately. All right, so let's go ahead and talk about this word problem here. All right, and this is where we bring in that number e, okay? So the exponential function f of x equals 1066 times e to the 0.042x models the gray wolf population of the western Great Lakes, f of x, and then x years after 1978. If trends shown in figure 4.6 continue, project how many the gray wolf's population in the recovery area in 2012, okay? So here's what we've got. Okay, so just so we know, all right, so all we're doing is just talking about this problem, not this one yet. So let's come up here, and we want to figure out the gray wolf population in the area of 2012, okay? So let's do this. Let's make sure we write this out. Let's write out that f of x represents the gray wolf population, okay? And then X, remember, is years after 1978. All right, so what we want to do is we want to figure out the X value that we're going to plug in. So we want to figure out the gray wolf population in 2012, okay, if the trend continues. So what we want to do is plug in a number for X, okay, a value for 2012. And so what I want to do, because X is the years after 1978, if we're trying to figure out 2012, we want to subtract 1978 from that to get the number of years after 1978. So when I subtract those two numbers, I'm going to get a value of 34. So what we are doing is we are plugging in 34 into this function, okay? And what I'm going to do is just write that out, 1066, okay, times e to the 0.042 times 34 power. Now, what I'm going to do is just type this into the calculator, okay? This is a calculator question, but it's important that we understand what exactly we are doing. So I'm going to type this in just how I see it, all right? So let me open up my calculator here. All right, so I got a calculator open, okay? And let's go ahead and type this in. So I'm going to do 66, okay? And then I'm going to multiply times, and then I go over to ABC, okay? And ABC contains that number E, okay? And notice what happens, okay? When I type in that number E, all of a sudden it gives me a number. I'm taking 1066 times this number E, okay? And then I'm going to go back to my numbers, and then we're going to raise this to an exponent, okay? And I'm going to put parentheses around my exponent, and I'm going to do 0.042 times 34. And what that gives me is this number here, 4,445.59. So what we're going to do, we'll just go ahead and round that to the nearest wolf. So f of 34 is equal to 4,446 wolves in 2012, okay? And that's what we're doing, okay? And that's the idea. So it's just same thing as any other function, except for we're dealing with an exponential function, okay? Don't worry about this next part. We'll do that part in class. So I hope you guys enjoyed this video. We'll see you in a bit. Thanks a lot. Bye.